So up until now, the only kind of triangles we've been able to solve are those with right angles, right? We've always been able to solve a right triangle because we have sine, cosine, and tangent. Well, now that we have the law of sines, we can solve oblique triangles, which is a triangle that's not right. So there's two situations in which we use this. The first is when we have angle, side, angle. So two angles and the side between them. We can also use it when we have angle, angle, side. So that's two angles and the non-included side. So for these two situations, we find the missing angle, just knowing that a triangle adds to 180. Then we're going to use the given side and the angle opposite as our base ratio, as like sine of A over A, and then use law of sines to find the missing sides. So first thing I'm going to do here is put my information on my triangle. So they tell me that angle B is 68 degrees, angle A is 69 degrees, and side C is 4. So the first thing I'm going to do is find angle C. And I'm going to say that angle C, or you can just use the big C, it doesn't matter. I kind of go back and forth between using the angle symbol and not, is going to be 180 minus 68 minus 69, which is 43 degrees. So now I have this 43, and so I have an angle and the side opposite. So this is what I call my base ratio. This is how I'm going to start using my law of sines, because law of sines says the sine of the angle over the side opposite, right? That's your ratio. So I'm going to have the sine of 43 over 4 is, let's find opposite B first. We'll just go in order here. Oh, order would be A, right? The sine of 69 over A. Right? So then I'm just cross multiplying, and I'll have A sine 43 is 4 sine 69. So A is 4 sine 69 over the sine of 43. Which is, let's see, 5.47. How do they tell me? Nearest tenth. So 5.5 degrees. And we don't have to put it on here, but I'm going to, not 5.5 degrees, 5.5, right? We're just finding a side length here. And then looking at now we need to find side B. It's always best to go ahead and use that same base ratio that we started with, because that was given information, right? So we also don't worry about a rounding error or something. So we'll say again that the sine of 43 over 4 equals, now I have the sine of 68 over B. So when I cross multiply and divide, I'm going to have that B is 4 sine 68 over the sine of 43. Which is 5.4. Those are pretty close together there. Let's see, 5.4. If you look at that triangle, I just want to point out that The angle opposite 4 is the smallest one, right? And the angle opposite 5.5 is the largest angle. It's just something to kind of keep in mind when you're looking at it and you're trying to think, okay, do these numbers make sense? That in geometry, in a triangle, the smallest angle is opposite the shortest side. The largest angle is opposite the longest side. So just something to kind of keep in mind. All right, so here we're going to put our information on. Angle A is 70, angle B is 69, and side A is 15. So here we have angle, angle, side. So here what we're going to do is go ahead and find our third angle, right? Because right now we could go ahead and use our base ratio. It would be right here, right? Because we have an angle and a side opposite. But we can go ahead and find the third angle pretty easily, right? And say that angle C is 180 minus 70 minus 69, which is 41. So when I do my law of sines, I'm going to expect side C to be the smallest one, right? And so it's going to be quite a bit less than 15, we would kind of assume. So let's go ahead and find side B. Again, that base ratio, or what I call the base ratio, we're going to start with the sine of 70 over 15 is the sine of 69 over B. Again, when I cross multiply and divide, I'm going to have that B is 15 sine 69 over the sine of 70. Which is 14.9. And then we'll go to the angle C. And we're going to have the sine of 70. Again, I'm going to start with that same base ratio over 15 is the sine of 41 over C. Again, when I cross multiply and divide, I'm going to have C is 15 sine 41 over the sine of 70. Which is 10.5. So like before, just pointing out here, let's see, that's 10.5, and this other guy was 14.9. So notice that 69 and 70 are really close together, right, in terms of the angles. So the sides opposite them are very close, right, 14.9 and 15. But the side opposite the 41 is 10.5. Again, it's just something to pay attention to for later.